Hello, everyone. Thank you for joining us today and welcome to our webinar on ATEX key insights and industry application examples. My name is Beatrice Miari. I'm a digital marketing specialist at Donaldson, and I will be your host for today. Before we get started with the presentation, I would like to go through a couple of housekeeping remarks. Please note that the content of today's webinar is for informational purposes only and should not be considered as legal or commercial advice. In case you need advice for your specific needs or use case, please contact us and we will support you directly. Today's presentation will last about 40 minutes and will be followed by a Q&A session. If you do have any questions along the way, please use the Q&A box on the right-hand side of the screen. We will try to address all the questions at the end. In case we don't get to answer your questions, don't worry because we will follow up with you directly. This session will be recorded and shared with you in a few days' time. For today's presentation, I will be joined by two exceptional speakers, Melissa Diaz and Richard Jones. I will now leave the floor to our speakers to introduce themselves and walk us through combustible dust, ATEX regulations, and some of our products applications. Over to you, Melissa.
Hello, everyone. Thank you, Beatrice. So I am Melissa Diaz. I have a background in engineering from the National University of La Plata. I joined Donaldson in 2022 as a product engineer, and since December 2023, I have also been responsible for legislation, meaning the Machinery Directive and the ATEX Directive. Besides this, I support engineering, sales, and project teams with practical and regulatory ATEX guidance.
Hi everyone, I'm Richard Jones, Sales Manager for the UK and Ireland with a materials engineering background and around 18 years of dust control experience. I've dealt with a wide variety of applications across many industries, focusing on food and beverage, pharmaceutical and transport manufacturing environments in particular. I really enjoy investigating such manufacturing processes and then providing the required dust control solution. For those not familiar with Donaldson, we are a global, very much technology-led company that has been around for more than a century, developing and manufacturing market-leading filtration solutions. We serve a diverse range of filtration applications within different industries across multiple business units. And in this presentation, we'll be focusing on industrial air filtration, which incorporates our fume collectors from BOFA, compressed air and gas filtration from our industrial gas division, and our main focus today, which will be the dust collector solutions that we provide. We provide those solutions from initial site visit to system design, manufacture, installation, and also then the ongoing spares and service requirements. As you can see, Donaldson have a large number of distribution, manufacturing and sales offices around the world, and that gives us the ability to serve our customers on both a local and also a global level. Okay, moving on to the content for this webinar, Melissa will begin by discussing the combustible dust basics and also an introduction to legislation, before I then run through a number of industry-specific case studies highlighting the challenges that we faced and then the solutions that we then provided. So over to Melissa for her section to start us off.
Thank you, Richard. So I will now explain the combustible dust basics. And to start, let's talk about an explosion and what is an explosion. So an explosion is a sudden release of energy that is accompanied by a buildup of pressure waves. What is important to note is that many materials can explode once they are in the form of fine dust and they are dispersed in a cloud. And besides that, there's also oxygen and an ignition source present at the same time. So what elements do we need to form a fire? To form a fire, there are basically three components. One is oxygen, the other one is heat, and fuel. Oxygen is present in the air. For our applications, the fuel is present in the form of dust, and the heat comes from an ignition source. So if these three elements are present, we have a fire. But what else is needed to actually have an explosion? For an explosion, there are two additional elements that appear. One is confinement, which is given by the limited volume in our dust collectors, and the other one is dispersion, which is the dispersion of dust particles. Here it is important to mention that the dust is only will only be explosive if the dust concentration is between the lower explosive limit and the maximum explosive limit. So within this range of dust concentration, we can actually have an explosion. But if it's below that minimum explosive limit or the maximum, there is no risk of having an explosion. How can we know if our dust will be explosive? Actually, how can we say like, maybe I should watch out for my dust? There's a basic rule of thumb which says like, okay, if you extend your arm and you cannot see your hand anymore, that's a good sign that you should maybe be careful. And the second one, if you see that there's a layer of dust accumulating in a surface and that layer is approximately 0.5 millimeters. Now, let's talk about the explosive properties of the dust. All the dusts have specific characteristics that are important to know in the case that the dusts are explosive. These characteristics are the Pmax, which is the maximum amount of pressure that can be reached with a specific dust. It indicates the maximum amount of damage that your dust can cause in an enclosed space. And this will depend as well on the particle size of the dust. Then there's the KST, which is the dust explosion index. And this is a measure of how quickly pressure can rise. Generally, this is given under control conditions in a laboratory. So it tells us how fast pressure goes from 0 to the Pmax. As you can see here, there's a dust classification. And here, the dust classification changes according to the KST value. So basically, the higher the KST value, the stronger the explosion will be. Another important parameter to consider is the minimum ignition energy, known as MIE, which is the smallest amount of energy or heat that can cause your dust to ignite. It's also important to consider if the dust is conductive, but here it is very important to know that the best practice is to have the dust tested at a laboratory that it's nominated by an end user, meaning that it's the end user responsibility to actually have the dust tested. Otherwise, there's information available online, but it's always better to test the dust. So, which is the role of dust collection? Our main goal is to keep the dust concentration below the lower explosive limit, because in that way we prevent fire or dust explosions, because we know the concentration is not enough to initiate a fire on an explosion. Then this also helps prevent the accumulation of dust in a workplace, because if the dust then becomes airborne, it can lead to an explosion. Then this dust that also accumulates in surfaces or corners can give place to secondary explosions. So those were the basics of dust. Now let's move on into legislation. So let's talk about ATEX. ATEX is divided into two directives. One is the economical directive and the other one is the workplace directive. The word ATEX comes from the French atmosphère explosive, and it is applicable all over Europe. However, many countries or many customers from different parts of the world sometimes request ATEX dust collectors, so it's something that it's welcome in many other places of the world. Now, talking a little bit about the ATEX directives. First, we have the ATEX 114, which is the economical directive. And this is the directive that applies to manufacturers, suppliers of equipment, for example, us, Donaldson. It gives technical guidelines and safety directions. And one specific thing is that member states cannot require additional measurements. And then we have the ATEX 153, which is the workplace directive. And this one gives minimum requirements for improving the safety and health protection of workers potentially at risk from explosive atmospheres. So this one applies to end user or employers. It also indicates which are the safety demands that all the end users must comply to. And differently from the other directive, in this one, member states can't require additional measures. Let's go a little bit deeper into the ATEX 153, which is the one that applies to the end users. Here, it indicates that the employer is the responsible person to have the explosion protection document and to assess if there are explosion risks. So this must be determined by the end user. Let's talk about the obligations a little bit more. Zoning is a legal requirement for the customers. Employers must assess the risk of explosion in their premises whenever flammable gases or combustible dust are present. And to do this, they must conduct an explosion risk assessment, which is required for the workplace. Based on the assessment, all areas will be classified into different ATEX zones, and these ATEX zones reflect how often an explosive atmosphere might occur. It is also very important to differentiate between dust and gas since they have a different zoning criteria. And it is also worth noticing that this applies to both new and existing facilities. And if there are some changes in the facility, then this must be kept up to date in the risk assessment. And of course, the end user must make sure to keep all the information up to date and maintain the explosion prevention documentation. So here there is an image showing the different types of zones that you can have. So as I mentioned earlier, it's different between dust and gas. So the less likely it is to occur, it is for a potentially explosive atmosphere to happen. We will be talking about the zone 2 or 22. So 2 is for gas and 22 is for dust. And if it becomes very likely to occur that you can have a potential explosive atmosphere, we will be talking about a zone 0 for gas and a zone 20 for dust. Here we have an example on the zone within a factory. As you can see, in one factory you can have many different types of zones. As a guidance for defining the zones, you can refer to the standards 60,079-10, part 1 for gas and part 2 for dust. And as I mentioned earlier, you can have different zones within the same factory. You can have no zones. Then here we have, for example, zone 22 right next to an office that it's not zoned. And again, this is the customer's or end user responsibility. Now, let's talk about the ATEX 114, and this is the one that applies to manufacturers or suppliers. This directive gives guidance on electrical and mechanical equipment. The equipment can be, in our case, dust collectors, but it can also be fan, rotary valves. Then we have protective systems like bursting disc, isolation devices, a little bit more on that later. Then this also applies to safety devices like overload protections and other components that are essential to the same functioning of all the elements mentioned above. Now, let's talk about which are the obligations of the equipment manufacturers. The manufacturer shall assess the product to determine whether they present any potential ignition source when used in a potentially explosive atmosphere. We must conduct an ignition risk assessment and document it in accordance to the EN standards. Here we must evaluate the potential ignition sources. That could be, for example, hot surfaces, flames or hot gases, mechanically generated sparks, static electricity, and even more. Then these potential ignition sources must be classified if it's for dust or for gas, because they have different requirements. And we must also make a distinction between group 1 and group 2. So group 1 refers to equipment intended for use underground, for example, mining. Well, it basically refers to mining. And then there's group 2, which is for equipment above ground. So a summary of the responsibilities, for example, at Donaldson on our side. We must make sure that we supply the equipment that is suitable for the potentially explosive atmosphere that will be indicated by the end user, meaning our customer will come and say, I have such zone, and we must make sure that we provide them the correct equipment for that zone. We should also mark the equipment so actually the end user can know, okay, this is suitable for my zone. And if there's any additional information related to safety, then we are also obliged to indicate this in our manuals. So now, which is the ATEX philosophy? It is important to know that the first thing is try to avoid creating an explosive atmosphere, because if there's nothing explosive present, then you cannot have an explosion. But of course, in many cases, this is not possible. So in that case, we try to remove any potential ignition sources. So we look at everything that can cause an ignition and we try to eliminate that. In many cases, we will not be able to eliminate all of the ignition sources. So we should try to avoid that the ignition sources come into contact with the potential explosive atmosphere. So we try to keep them separated. But again, in many cases, this will not be possible. So in this case is that we will use mitigation systems to limit the impact of an explosion. For example, here we would use venting devices, flameless venting, isolation valves. Now let's talk a little bit more about the zones. As I mentioned earlier, the end user will indicate the zone, and we must make sure at Donaldson, we provide the correct equipment category. So for example, for a zone 22 dust, we must provide an equipment that is at least 3D. Now let's talk about the marking. Here it is very important to mention that units will have the marking only if they are placed in a potentially explosive atmosphere, but that's different than handling explosive dust. More on that a little bit later. So here we have an example and the marking of how the marking is created. We have the hexagon, the group 2, which refers that we are above ground. 3D, that's the equipment category. And here we indicate also the temperature class. Now, indicating the temperature class is important because it determines whether the equipment can operate safely in a hazardous area without igniting the surrounding gas or dust atmosphere. And now let's see some examples. In this first example, we see a dust collector that it's placed in a potentially explosive atmosphere, but it is not handling explosive dust. So this unit will have an ATEX marking, and it will be according to the zone. In this case, the zone indicated outside the dust collector will be a zone 21. So we must make sure the equipment we provide is set to the equipment. And as you can see also, the marking will have the hexagon. Moving on to the next example, here we have a unit, a dust collector that is handling potentially explosive dust, but it is not placed in a potentially explosive atmosphere. So here it does not fall under the scope of the ATEX directive, but under the scope of the machinery directive. And this unit will not have the ATEX marking, but we will indicate that it can handle potentially explosive dust by the triangle that you can see in the screen. And the last example here, it's where we have both cases together. So we have a dust collector handling explosive dust and a potentially explosive atmosphere outside the dust collector. In this case, we must apply both the ATEX directive and the machinery directive. The unit will have the marking and the hexagon, and as well, it will also have an indication that it can handle explosive dust with the triangle that you can see at the bottom of this image. Now, moving on a little bit with mitigation options, because I mentioned that many times it is not possible to actually avoid an explosion. For that, we use these solutions to get a better outcome. For example, we can offer different media options. We have flame retardant media. Also, we must make sure that with the minimum ignition energy is below 30 millijoules, the media is conductive. We also have inlet isolation to prevent an explosion from propagating to other areas of the manufacturing facility, for example. We have venting devices that allow to release the pressure buildup before it goes much higher and it can be much more dangerous. We also have suppression systems that are very useful in the pharmaceutical industry and flameless venting devices to avoid flames to get out. Then there's also isolation for the hopper, meaning an isolation from the place where we are actually accumulating the dust. So to prevent that another potential ignition source in the dust disposal system. And we also have outlet isolation. For example, here we have a bulb that can help stop fire and explosion propagation from both sides, so not only from the side of the dust collector, but in the case that there could be a potential ignition source from the side where the dust is being handled. And then we also offer, for example, sprinklers. So that's what I have to say about mitigation examples, but those also apply to explosions. Now moving on with the industry application examples with Richard.
Thanks, Melissa. So now we've heard the technical theory behind ATEX in dust control. I'm going to run through a number of actual case studies in some of our focus markets where explosive dusts are particularly prevalent. So the first we're going to look at is the food and beverage industry. And here the majority of the ingredients that are being used to manufacture the finished goods are potentially explosive. Often they'll be in the lowest ST1 explosion class that Melissa alluded to in her presentation. Indoor dust collector installations are sometimes preferred, and those will prevent the interaction of the hygroscopic or moisture absorbing dust with condensation in the ducting or piping or dust collector, for example. With an indoor installation, it's easier to stabilize the extraction air temperature, and the dust can be kept dry and free-flowing through the dust collection system. In such cases, filter cartridges can be utilized rather than filter bags from our Donaldson Dalomatic range that we tend to use then for higher dust loads, sticky dusts, and these moisture-laden applications. Reinforced dust collector will need either a horizontal or vertical explosion vent duct to then vent that explosion to atmosphere, or more commonly now, a flameless vent device. Away from the explosive dust-related safety issues, there are also concerns within this industry regarding airborne dust and the health of workers. So with dust control helping to prevent such issues that are commonplace then, such as asthma from flower dust, for example. This industry is also famous for producing a high volume of low-cost goods. And that means capital expenditure on dust control projects in particular is very sensitive. Therefore, the correct solution must be found that provides good value, energy efficiency, and also reliability. As frequently here, we're considering very busy 24/7 operations. So taking the first real-life case study itself, we're looking here at a convenience food manufacturer. And in this facility, there are old, non-compliant shaker dust collectors, and these were looking to be replaced with the current technology. The existing dust control systems had been added to over the years and were no longer working very effectively at all. The end user's health and safety department led this particular project, and the initial site survey we undertook highlighted a number of issues relating to ATEX compliance and also the workplace dust exposure levels. The solution that we provided, that you can see there in the picture, is a Donaldson Torrent DFE dust collector with explosion prevention and protection features. That also includes the flameless vents that you can see on top of the collectors for safe internal explosion venting. Here also, to make the on-site transport and installation of the dust collector simpler, we delivered that DFE 324 in sections. Also included with this, that you can see, is the non-return valve or back flap valve, the floor-mounted fan, and also the bespoke controller. And that had an inverter built into that controller for a very efficient fan motor control. Now looking at the next industry that we're going to consider here, and that's the metal industry and sort of engineering environments in general. Here the challenge is we're also focusing on explosive metal and alloy dusts, and some of these will then take us up into the higher explosion dust class of ST2. These metal dusts include materials such as aluminium, iron and titanium, for example, and all of these will carry a dust explosion risk. These dusts are being generated from numerous well-known processes such as thermal cutting, and that can be with laser or plasma torches, finishing operations such as polishing, grinding, linishing, and also thermal spray. And with thermal spray is where a metal powder or wire is superheated and then added to the surface of another component. Some of these processes will be producing hot material and or sometimes sparks as well. So this material must be prevented from entering the dust collector and then creating that ignition source or fire risk that we're trying to eliminate. Many of the alloys that we come across are proprietary materials, and these don't have the dust explosion data that Melissa discussed, namely the KST, Pmax and MIE values. So we always request that dust explosion tests are then undertaken to provide this specific data. And it really is the end user's responsibility to provide that information, because it's their dust, their processes, and essentially also their risk assessments then, which are going to be used. Now looking at the particular case study here, this was a project with a global aerospace manufacturer, and they have very stringent guidelines as to the health and safety demands. And that was both on the specification of the dust collection system, but also the installation. We were dealing here with a metal alloy, which was tested on our request. And that dust explosion data, which we were then provided with, led to much lower than expected results, and therefore a big saving in that level of explosion protection equipment that we then had to provide on the dust collectors. You'll see there in the picture a Donaldson DFE 424. That was installed outdoors with standard vertical explosion venting, as well as the non-return valve. That was all rated then for metal ST1 dusts. Again, here there was a floor-mounted fan and also the inverter-controlled motor. And what we were able to achieve with this particular project was really good filter life, filter service life, and also energy cost savings. And then particularly in comparison with the performance of that solution compared to other dust collectors on site, that enabled us to work consistently on subsequent replacement projects. Now looking at the pharmaceutical and chemical industries. We group these together typically because in most instances we're handling very similar, very explosive dusts, usually in the ST2 range, but occasionally they can creep into the ST3 range. These dusts also can be very toxic and require containment solutions to provide to sort of prevent any of the significant exposure to the actual operators themselves. Often we have very limited space in which to install the dust collectors. They're sort of being sited within very congested plant rooms. So a compact solution is often really, really important. We also have to consider the addition of some potentially explosive solvents or gases in the extract air. And then when you combine that with also explosive dusts, that can create a hybrid mixture. In these instances, we have to take extra care and then work closely with our explosion prevention and protection equipment suppliers to configure a very specific dust collector solution. Some typical processes that we'll come across within these industries include tableting and coating, mixing, blending, spray drying, for example. And here the certification and documentation requirements for such projects are very extensive. We have to really rely on all of our technical resource and experience gained across many years dealing with such projects in this industry. The case study that we can see here was for a pharmaceutical customer in this instance. This company was processing very fine APIs or active pharmaceutical ingredients. And these had a tested ST2 dust explosion class. This site in question had very strict safety requirements for the handling of this product. And that was really stipulated by the company's environmental health and safety department that we worked closely with. But also there was a site insurance provider that also was involved with this to ensure the solutions that we provided they were happy with. With the proposed dust collector that was actually installed outdoors, it was decided that a chemical suppression system was still the safest option because of the toxic nature of the dust. So the aim really of these suppression systems is to prevent an explosion from propagating through early detection. And along with the containment features that you see there, the sort of bag in, bag out for the filter change, etc., we ensure then that the toxic dust couldn't escape into that surrounding area. Moving on now to the next case study in the waste management and recycling area. So here we really come across some very unique challenges. So we're finding ourselves again in very busy, often continuous manufacturing environments, and not only with dust explosion hazards, but also considerable fire risk. And that's really coming from the stockpiling of materials and also the handling and the unknown consequences of batteries and the ignition sources that they can create. There'll also be a very diverse mix of materials being handling on these sites, and these materials, once processed, are generating both dust and also fibrous material, which, although the fibers themselves cannot create an explosive atmosphere, the combination of which will still require a reinforced dust collector with explosion prevention and protection features, particularly if that dust is explosive. And that dust really is becoming explosive during that filter cleaning cycle, where that dust is blown off and can create a more of a concentration inside the dust collector. The fibers themselves can combine together and create blockages in more typical cartridge and dust and baghouse dust collectors. So we have a very specific dust collector design, which we're able to implement in these situations. The sites are also very tightly controlled in terms of the limits set for emissions, both in the workplace and also to the external environment. And sometimes we're also having to consider some noise restrictions on the equipment if these sites are in close proximity to a residential housing development, for example. Now looking at the solution we provided, this time on a car recycling plant. All of the challenges that we mentioned were applicable on this site. So here we are handling a mix of explosive dusts, but also fibers. So the optimum solution was our PowerCore dust collector, which you see in the drawing there. This unit comes complete with the PowerCore filter packs, which are able to deal with both the dust and fibers. And these packs, the filter media involved, really helped significantly reduce the emissions to atmosphere in comparison to the previous bag filters in operation. The roof-mounted fan is an acoustic fan box, and there's a rear-mounted flameless vent. And that was used really because a safe area for standard explosion venting couldn't actually be found in this instance. Due to the bulky nature of the dust and fibre mix that was being generated once we'd collected that airborne material, we provided a large capacity bin, and that made the waste product disposal much simpler and a less frequent operation than for the workers. Now moving on to a more unusual industry that we've sort of grouped here in the final case study. And this involves a group of materials known as composites, which are becoming increasingly common, that we now come across due to the advances in materials technology in this environment. They consist of combinations of a variety of materials, including plastics, carbon fibre, glass and resins. And this combination can give a very strong but lightweight material that has very useful engineering properties. Composites are often found in transport manufacturing, namely aerospace, rail, marine and automotive. And it's really here where these properties of strength and their lightweight nature can give the most benefit. As such, these components being manufactured can be quite large, so trying to capture the dust from source can be really challenging, even if you're using flexible arms. The dust being generated can also be very fine, explosive in nature, typically ST1, but also carcinogenic. The fine dust is usually generated from finishing operations. Typically, here you're thinking about trimming, sanding operations. And as the finished product has to be of a high quality because of the finished product obviously has high safety demands, then the removal of dust from these components is also important. So the last example we show here is the Donaldson ECB, or Environmental Control Booth. And we installed this within a rail component manufacturer that were making very large component parts. This ECB provides a very large and comfortable environment for the operators to work in. And with that airborne dust being generated, it's very effectively extracted by the power modules, which contain both the cartridge filters and fans, and that's located at the rear of the booth there. The dust is prevented from escaping into the surrounding work environment by that continuous flow of air, which is drawn from the front of the booth opening that you see. There are ATEX rated lights inside the booth for excellent visibility, and with no need for flexible arms, the operators can focus on the job in hand rather than having to move flexible arms into the required positions, for example. The ECB is an ATEX compliant solution with ignition source elimination features, and also has the option for integrated HEPA filters that you can see there on the drawing. And that helps then to provide clean air recirculation. So although we're extracting quite a high volume of air, we're then replacing it back into the workplace and making sure that air is as clean as it can be. The installation of ECBs is very quick and simple, and there are no ducting or pipework requirement. So it's literally arrives in kit form, can be delivered as such, and then installed nice and quickly and up and running in no time. So that concludes now the main content of the webinar. So to really summarize what we've been discussing, some of the key takeaways should really be related around the ATEX compliance, and that really is a shared responsibility, which entails the sort of safe design, correct equipment selection, and also the proper operation of the dust collectors in particular. Understanding the zoning is really critical, and correct classification will then help drive the right technical decisions being made to ensure that whatever is installed is compliant then through every level, every particular component part. Explosion prevention should always come before explosion protection. The more we can prevent a dust explosion from occurring, then the safer that system in operation. But then, as the background safety measure, then all of the protection measures can also be in place to ensure that system is compliant, as we said. A really important point this is manufacturers, so that's Donaldson, suppliers of equipment and components that we use, installers and end users, and a mix of those we have attending the webinar today. Everybody's got to work together. It's very much a collaboration, and by collaboration and providing all the information that we need and the risk assessments, etc., then we can ensure that installations and workplaces then become a much safer and compliant place, and very sustainable for the future. As a company, we're very keen to work on any dust control requirements, and we can really be trusted as a partner to support with this ATEX regulation demand. So we are here available to work with you, provide the guidance where necessary, to really support that collaborative approach. We're also very happy to continue that conversation and share any of the sort of current and future projects that you may have then with our technical experts. Here you can see some of our contact details. You may already be working with your local territory managers who can then really support you with these projects going forward. I'll now hand back to Beatrice, I believe, for the Q&A session.
Yes, thank you so much, Richard and Melissa, for sharing these insights. Yes, opening up to questions, we have received a significant number of them, so we'll try to address as many as we can today. The first one we got is, can ATEX components be retrofitted on existing collectors?
I think I can take this one. Here it is important to remember first the different types of collectors that we can have. First, there are the collectors that are not meant to handle explosive dust, then the collectors that can handle explosive dust, and then the ATEX collectors, which are the ones suitable to be placed in a potentially explosive atmosphere. So for ATEX collectors, ATEX components can be retrofitted, but only if the system will still meet all the essential health and safety requirements of the directive. If this retrofitting does not create a new or modified product, unless it is accompanied by a full conformity assessment. And in case of these modifications are done, then it's the entity performing the modifications will become responsible of ensuring that all the safety demands are met. So as long as it doesn't change the intended use, it could be okay, but if it's considered a new equipment, then the responsible part should look further into it and make sure that there's a new risk assessment.
Thank you, Melissa. Moving on to the next question, is electrical bonding earthy of the duct pipe system always necessary?
I think I will also take this one. The answer is yes, because the movement of dust, especially conductive dust within the duct, can enable the buildup of a static charge, and this creates a potential ignition source. So yes, basically you need it, and by doing this, you also protect the workers from a potential electric shock.
Thank you. Next question we have is, do you have a list of dusts that need an ATEX dust collector?
That's probably one for me to answer. So we don't have a specific list per se that we can issue, but we do have a database, and that's held by our technical department, that we can reference and actually contact them, obviously, to get that information that we need. And all of that, that information has been based on decades of application experience that we've had. So probably your best first port of call would be your local territory manager, and they can run through some of those details with you. Also of interest is there is a database on the internet that you can reference as well, which gives some good guidance. It's actually a German-based website by IFA or Gestis. So we can provide you with that link, and what you can do there is tap in that specific material and then pull up some really useful actual dust explosion test data, which you can then show your various parties involved in the project, just to prove that dust is explosive, and then it's worth obviously getting it tested to get that specific data then. Also, we're on that subject. We have a dust collector and combustible dust management brochure that you can find on our website. And that gives a really good background then as to everything that we've been discussed here and our capabilities as a company, Donaldson, to help you.
Thank you, Richard. The next question we received is actually coming from one of our distributors. What if the customer has a non-ATEX unit and uses it to extract aluminum dust or normal steel dust from a laser cutter?
Okay, I will take this one, I think. First, again, let's remember the important difference between non-ATEX and reinforced, or meaning dust collectors that are suitable to handle explosive dust. So in this case, if we are talking about extracting aluminum or steel dust, I would say that at least it should be well, for sure. We should talk probably about dust collectors that are suitable to handle explosive dust. So definitely not a standard dust collector, and probably it might also not be needed an ATEX one. Now, when it comes to aluminum dust generated by thermal cutting, it might be that not all particles are fully oxidized. This means that dust can remain combustible, and therefore you could have a potentially explosive atmosphere. So in this case, the dust collector needs to be suitable to handle explosive dust. Now, if the same collector is also used for steel dust, there is another risk of layer, because when aluminum and steel dust are present together, there is a potential for a thermite type reaction. These reactions burn at extremely high temperatures, so they can create a significant hazard. In all, I would say if you are not 100% sure that the dust is fully oxidized, then it's better to go for a reinforced dust collector, meaning a dust collector that is suitable to handle potentially explosive dust. Some customers do know that the dust is fully oxidized.
Thank you, Melissa. Moving on to the next question that we received. Do you have training guidelines for service engineers working on ATEX dust collectors?
That's probably more in the sort of sales environment, so I'll answer that one. So there's training, but no sort of guidelines as such. So if we take Donaldson service engineers, for example, they'll be internally trained on sort of dust collector explosion prevention and protection considerations. And obviously they'll gather their own experience through dealing with all the various different sort of ATEX rated components that they'll then see that are installed on the various dust collectors that they come across and service. Now, those service engineers will then also be supported by their local territory managers or sales engineers, and then they can work collaboratively together to provide that sort of technical support on whether that dust collector, which may well be very old and maybe non-compliant, and then what is required then to then feed that information back to the end user with the right kind of advice as to what they need to do to get to that level of compliance again. So certainly speak to your territory manager really as the first as the first person, and then we can provide all that technical support then.
Thank you, Richard. Next question is a bit more technical. What are the consequences if the duct pipe velocity drops below 20 meters per second?
That's probably more me as well, actually, being a system query. So 20 meters per second is really what we use for heavier dust types like metal dust, for example. So there you need obviously a faster duct velocity to ensure that dust is effectively conveyed. However, some of the lighter dusts, you can actually move effectively at, say, 15 meters per second. And particularly in the UK, that's seen as the sort of base level, really, for where they're then doing the testing for the suitability of the dust control system. So what we can do is work out what transport velocities are suitable for the particular dust type that's being generated, and then build that into the design. So all of that will be taken care of by our project engineers and territory managers. The issue that you get if that dust isn't being transported effectively with a low duct velocity, that dust can then accumulate in that ducting. That then obviously creates potentially particularly a secondary explosion risk, but also a fire risk, and also create possibly some hygiene issues, for example, if that dust is within a food environment, for example. So we've also had the case where too much dust is collected in some large old ducting systems, and that's led to a ducting collapse. So those transport duct velocities are really important and will be considered really at the front end of any project.
Thank you, Richard. I think we have time for a couple more questions. The next one is a more general one. I have a factory with issues of dust. How do we start?
I think probably best I carry on. So as sort of Melissa ran through, the best place to start is really finding out if that dust is explosive. So get it tested with a local laboratory. So there's a number that'll be found, whatever country. Once you have that information, then it would be your Donaldson territory manager would be a next port of call, really. They'd be able to assess that dust and then really provide guidance as to what that dust collector specification should look like. And often the best way of doing that would be a site visit to really look at the process and all the other process conditions around there, looking at where that dust collector will be installed, to then work out if explosion venting is required, for example, how best that will be achieved.
And the last one for today, what filters do I use for ATEX?
Do you want me to take that one, Melissa?
Yeah, you can take this one.
Okay, no worries. It's a good question. It's filter selection. It's a really big topic that we'll be covering then in a future webinar, no doubt. When we say we're considering ATEX, then we're really considering the dust minimum ignition energy. So if it's of less than 1 millijoules, for example, then we need to really start applying anti-static filter media, along with then looking at perhaps some earthing considerations as well, to make sure that we're not creating that potential ignition source from the actual filter elements themselves. So that's really the main area of that topic. When we look at plastic dusts, for example, they can create a static charge as well. So we'd also look at using that anti-static media in those instances for those dust types as well. So we've got a big aftermarket team that can assist you with some of the selections there, as well as the territory manager. And then whatever dust collector we come up, we'll then make sure that we're also then installing all the correct filter media for there. I think that's it.
Yeah, thank you, Richard. That actually brings to the end of today's webinar. Huge thank you to both our speakers for sharing their insights and expertise, and to all of you for joining and engaging with us. Before you go, please take a moment to leave your feedback about today's sessions, but also let us know what topic would be interesting for you for a future webinar. We have also some links to additional resources, direct links to get in touch with us and follow us on social media. And with that, I thank you all again, and I hope to see you in our next webinar.